So even with some of you, some of your classmates, not some of you, but some of your classmates gone, not that you can speak for them, but in your estimation, they have the opportunity to go back and view this if they so choose. But what's the hardest part about this problem solving so far? Is it deciphering what it is you're looking for, or is it the just the how the problem is worded? Little input. Or maybe you don't know until you get to there. Okay, so we're leaving some breadcrumbs for you to get from point A to point B. Okay, is that a general consensus? So having more practice for that, you think that would be beneficial? Yes? Okay. All right. So, call this shooting from the hip. In other words, we're going to do a problem on the fly. Okay? So what that means then, well, you look better with the hat on. Don't have a glare then coming off the lights. Okay, well, we'll put them on again anyway. I don't know. Am I playing the part all right? Yeah? Okay, fair enough. Fair enough. All right. Okay, so, what could we do here? About I don't even know if that's spelled right. Rhinoceros. I believe that's got to be close. And maybe there is. Okay. Our so as we continue, even if we didn't go any further, what formula would you be dealing with if we're talking about mass? Where would that have been the momentum formula? That's the only one out of the three so far that what we have mass in. Okay? It's not velocity and it's not acceleration. Okay. Oh, certainly. Yes. I don't want you to memorize them. You probably will throughout the course of the semester, but at this point, no. We want you to know how to use them. Okay? Oh, we'll go ahead and go 4.14. Yeah. Well, that would be true, but you'd have to have two. I'm not done writing the problem yet. Okay? Oh, we'll go ahead and say. No, he's not moving that fast. And calculator work to get a spit out a number here, so please just bear with me. Okay, so now let's give you a little bit of time to catch up writing all this. The idea was have that black licorice, keep chewing it up and filling it up so the drool comes out of the mouth, but I can't get that much licorice in my mouth. Ugh! Eventually it just doesn't taste any good anymore. Okay, so, and I believe we've got enough information up there. Okay, so as we look at this, you've read the problem. The next thing we want you to do is what? Yeah, because in other words, in order to get this finished, we need to know where to start. Because we're looking for the mass, and where you see that mass formula, how many variables are in that momentum formula? Well, there's 3, okay? So you have to know 2 of those variables, and we have only what? We only have one of those variables. So let's write down what we know, and then we can move forward from there. Okay, so what do we know in this problem? Now, you're right, but how? It doesn't say it accelerated. How do you know that it's an acceleration? Because meters per second squared, okay, that's right. Oops. 6,241.80 kilograms dash meter over seconds. Now, there's what we want to call an unwritten variable in there to where you need to use your physical science or physics intuition here. We still have to account for one variable, not the distance. Once you figure it out, you can say, God, I knew that, but I didn't want to say anything in front of the group. I see my light is blinking. I'm afraid my batteries were low on power, so I'm going to switch batteries really quick. That sends a signal to here. It's a microphone. Okay, we'll see how well this goes now. Okay, so we still need to account for one variable. So just read in the problem, because once you figure that out, the next time you see that, you're going to know what it is you're looking for. Okay? Kind of like if you follow baseball, when you see that ball spinning like this, that's maybe a slider or curveball coming in, then you know what to look for after that. So, as we're reading in the problem, does anyone see, don't say anything, does anyone see the last one that you need to put down here that we know. Then once you have seen it, okay, there's 1, there's 2, 3, 4, 5. Okay? Because now when we go through this, next time you see this, you can say, oh, now I know what it is we're looking for. Okay? So here's your clue. Okay? So yes, you have those two rival males that are going to collide with one another. Okay? But we're not concerned about that conservation of momentum. Okay? What we want to know is what had happened if one of them was accelerating at this speed, or that acceleration. How fast did it go when it started? And how do we know that it's 0? It begins from rest, right there. Okay. So now, next time you see that, you're going to say, if it begins from rest, we know that that's a specific velocity, and that is which one? That is your initial velocity, because you had correctly said that in this formula, okay, we've got this one and we've got this one. So how you would look at that is, as you have this information down, the question is asking for, well, what's the mass? So we're looking for this guy right here. But what's the problem with that? How many of those variables do we have? We only have one variable, just this one, the momentum. Okay? So, if we have this one, we're looking for that variable. Do we have the final velocity? No, but we can get that information. Okay? So now is one of those aspects to where you look at the information that we do have. You correctly said we're looking for the mass. We don't know what that is. Okay? So that information's right there. We have the momentum. We don't have that. That's why we put a box around it. But how can we get that final velocity? And that is where, when you look at the rest of your formulas on your formula sheet, you look and you would say, okay, I'm looking through this. Okay, I have an acceleration. Okay, I have this variable. What else do we have in our given? Okay, we have our initial velocity. So we have this one, we've got this one, and we've got the time. So when we have these three variables, now we can solve for what? Now you can solve for that final velocity to give us that critical variable to finally solve for the mass. Okay? So that's why it's, in our estimation, how we want to approach these, it's critical that you write this information down, so now you can look at your formulas and say, okay, we've got 3 of the 4 variables here. Okay. Can we proceed forward? Left side, are we good? Right side? Okay. I couldn't remember. There's 2 batteries that are charged, there are 2 are not charged. So we'll see if... Okay, take what, 2 or 3 or 4? Let's see. See if see how long it goes before maybe this light starts blinking again. But if it goes out, we still can we're able to see the video. Just won't be able to hear anything. Okay, so how are we going to get our final velocity? That's from which formula? Acceleration one. So let's do what the formula tells you to do. And that is what? Where does your value for your acceleration go in your equation? On the left side. So we don't have to look up at this problem again. We have all the information we need right here. So 4.14. We don't need to put our label because we did that over here as well. So that equals what's on the right-hand side now? It's a fraction. So what goes here? The variable we're looking for. You can put minus 0, but you can just leave it as VF up there if you're okay with that, because you take 0 from number or variable, you're just going to get the same amount anyway. So what goes downstairs here, which we see in our setup, is 2.70 seconds. Okay. Now, next thing you can do, we're not changing the value of that, but I think it's easier to see the next step that you're going to do. We're going to cross multiply. So if we take 1 times VF, what do we get? VF. So that's the variable we're looking for. So if we cross multiplied here, what do we do with these two numbers then? Cross multiply, and we get, okay? That's meters per second now. And more importantly, it's our final velocity. So now what we can do is say, okay, we've got our momentum now, and how are we going to finish this problem? You tell me what to do. Well, you're right, but let's write it in our equation format so we can see why you're doing it. You're right, but so how are we going to write this though? Okay, 6241. Okay, that was the product of our momentum. So that is going to equal what's on our right-hand side now. M times 11.18, or we can write it like this, 11.18 M. Now, how do we get mass by itself? Okay, we're doing a multiplication function here. So to undo that, we have to divide. What you do on one side of the equation, you have to do on the other side. So therefore, our mass is what? 558. Oops. Okay. 30, something to that effect. All right. So it'll be your classmates. This light's blinking. I gotta charge these batteries, but they get the idea. So, is there anything else that you feel that you would like to go over? This is your time and your opportunity. If you feel I'm comfortable with these, we can be done going over these. If you have a good understanding of these, and I get it, you put the term exam or test. It's like, I don't know what to do, but the best thing that you can do is write down your information and proceed forward. The reason for that is you're going to have more and more variables as we proceed forward, and for those of you taking this and post-secondary coursework, whether it's chemistry or physics, you're going to have to do something very similar. We want you to be successful when you leave these doors for the last time, and that's a little over 3.5 years, so it's not that far off. It seems like it's a long ways, but the example that we had given is Tokyo hosting the summer games. I think they are. So once they know that they are hosting the 2020 Olympic Games, it's not from 2016 to 2020. It's not wait till 2018 and say, oh, I suppose we better start building some of these structures. If you do it that way, you're not going to get done in time. Okay, so our left side, are we good? Sure. erase this. All right. So what we mean by that is, I don't know, there was a movie that came out before your time called The Ring. Anyone ever heard of that? Did you watch it? It's kind of creepy to me because it's a horror movie. I can't remember what the plot of the movie is, but you know when you hear the title, the Ring, well, it has to deal with this ring that has to deal with a well of some sort. So maybe the only reason that popped into my mind is some of you are probably going to go see Stephen King's It. No? Does that sound good to some of you people? The movie It? It doesn't sound good to me either. So, but some people are going to say, yeah, I'm going. Okay. Anyway, so in this case, one of the best ways we look at this, okay, so you find a well. How deep is this due to dropping? There's only one P dropping. So there's two? Okay. Dropping. What are we going to drop in here? Oh. How about a person? Should we throw a person in there? The acceleration is going to be the same whether it's a ring or a person. Okay. Okay. And okay, people, we're throwing Tanner over the side into the well. Okay. So how many seconds have gone by? How many of you want 3? How many of you want 12? 12, that's a pretty deep well. That's why you picked it. Okay. 7.4 seconds later. Okay? Now, so as we look at this then, okay, as you people are holding Tanner over the side, he's not moving, then all of a sudden you're going to say 1, 2, 3. Everyone moves their hands and down the well he goes. It's so big that he can't reach the sides to slow himself down, that his legs are flopping, his arms are flopping, and are you saying anything or just he just accepts it? Okay. Okay. So, what would be your next step? So, the reason we say that is there's something that's not written up there, the acceleration, but we know what that is because it's moving in the vertical plane. So it's moving or accelerating at what rate? 9.8 meters per second squared. We want to make sure you say that squared so we know that it's an acceleration. So, our acceleration. So before everyone hit 3, we knew a velocity. It was 0. Okay? And what else? We know the time, which was okay. So with these 3 variables, do you see acceleration in the velocity formula? Well, when I say velocity, it's when you're solving for velocity only, because we know velocity equals what over what. So it's kind of a trick question. But my point is, how are you going to start this problem? With which formula? Your acceleration formula, because we know that, because we need to solve for what first? We need to find that final velocity, okay? And then once we have done that, now we can get the distance or the depth. Okay, so do what the formula tells you to do, and that is put your acceleration on one side. So what goes on our other side? Okay? But we're just going to put the final velocity here because remember, initial was 0, so we're not taking anything away. So what goes on the bottom then? Which is 12.74 seconds. What did you do?